Okay, so we're going to talk through the very basics of electric circuits. Things we're going to review are the definition of what an electric circuit is, the path of electrons in a circuit, the needed materials or conditions for that circuit, and the path of electrons in a light bulb. First, what is an electric circuit? You can see the little picture on the top. That's an idea of what an electric circuit looks like, but what does it mean? It's a closed conducting path along which electrons can flow. You can see the picture on the top is a closed path. It's like a big circle, and that's the kind it is. It's conducting. It's made up of parts that conduct. It's not made of wood or straws or anything like that. It's made of all conductors, in this case metals, and electrons are allowed to move along that path because it's a conductor. Okay. The path is conducting. So it's full of electrons that are allowed to move. If you remember from chemistry, metals are ones with lots of the sea of electrons, those loose electrons that move along it. So if one electron starts to move because of that battery or power source, other electrons along the path are going to move too. It's kind of like if you push one thing, it's going to push all the other things that are in a row with it. So it's going to make a flow that starts instantaneously. So you don't have to wait for one electron to go all the way through. In fact, that would actually take a little longer than you would think. It's different than the flow of water in a pipe, because in a pipe, you have to wait for the water to turn on and for the water to get all the way there. But in a circuit, it's already full of water. So the minute you close a switch, there is a flow of, or the electrons start to move. And the electric current, which is the rate of flow of those electrons, they're not jumping across like they are, say, at a Van de Graaff or something like that. Okay. What are the materials that you need to actually have an electric circuit? Well, obviously you need some kind of battery and a power supply, something to give you energy to make the electrons move. You need some conductors to hook everything together. You can see in the picture over there, there's two wires there. Okay. You can see a device that does something, in this case with a light bulb, a heating element, sometimes they're resistors, and a closed path that connects the device and the battery. So you're going to have that, again, that circle quality that makes all of those things work. And you're going to have a connection to the positive and negative terminal of the battery or the power supply. Notice there's a positive and negative terminal on the battery, the plus and the minus, and a positive and negative terminal on the power supply itself. You have all those things. Okay, so we're going to talk about the path of electrons in a circuit. And electrons are negatively charged, stuff you know from your chemistry class. Okay, they move away from the negative terminal because electrons are going to repel each other, and they're going to move toward the positive terminal. And you can see that actually in the little picture over here. It shows the arrows. It moves like that. It's going to go across here and through there. And notice I ignored what happened in the bulb there. I just said that's the path. So in this case, they're going to move around like that. In our circuit here, the one that's on the bottom, you can see that they're going to start from the negative, go around here through that bulb, and around up to here. That's the direction they're going to move. So that's going to be our closed path, our closed circuit. Okay. So next, the path of electrons in the light bulb. Well, light bulbs need a connection in two places. Now in the picture they showed a weird kind of light bulb, and they have these where they have like two little points on the bottom where they connect. But all these incandescent light bulbs have one on the tip at the bottom of the bulb. You can see it marked down there. Okay. They also have on the sleeve on the side of the bulb. There's actually a black space in between you can see, and that's like actually an insulator. You can't connect anything there. It doesn't matter whether electrons enter at the tip or at the sleeve, as long as there's a connection on both. Okay. In other words, they're path independent. The charge can go either way to light up the bulb. But between there, they're going to travel up one support through the filament and back down the other support. I'll show you the pieces I mean. The supports are those two little things that look like antennas along the side. And the filament is the part that actually does the lighting up. So let's take a look and I'll show you what the path looks like all across here. Okay. So if it started at this, if it started at the tip, it would go up here, through there, down through this part here, and out through the sleeve. That'd be one way to keep track of it. Okay. In the little bulb at the bottom, the same kind of thing happens. It would go like this, around here. In this case, you can see it's connected at the sleeve. So it's going to go up this way, around there, through the tip, and out this way. Notice it looks like it goes through that sleeve again, but it's really going underneath. You can't really draw it a different way. Let's look at two examples of circuits that have batteries and light bulbs in them. This one has two light bulbs and they're connected together. But remember, you have to have a connection at the tip and the sleeve to make a bulb light up. So I'm going to start from that positive end or negative end over here, because that's where the electrons are going to go. I go up to here. For the light bulb to light, I'd have to have a connection at the sleeve or at the tip over here on the end. But I don't have a connection there. Since I don't, it's not going to go through there. It's going to just keep going along here. Okay. So I'm going to redraw my path. It's going to go like here. It's not going to go there. Now it's going to go to that one. Now if it's going to light that bulb to get to the filament, it's got to go up through those supports and it's got to go out through that little tip at the end. But there's no connection there either. So we're going to have to get rid of that. We don't have anything there. So we're going to have to go from there all the way along like that. So we're going to actually have current that goes all the way through. We're just not going to have an actual lighting of any bulbs. Kind of weird, but it does make sense. In our second piece here, we've got two light bulbs set up almost the same way, but this time you can see that one of the wires is connected to the tip. So this time it's going to go like this again, up to here. It's going to go up underneath through here and out through the sleeve. This time, again, it's going to go over here. No connection over at the tip, you can see. So it's not going to go through that bulb. It's going to go all the way to there. That's the path that it will take through the bulb and through the circuit. It's going to go counterclockwise, but it's also going to go through only bulb 2. Bulb 2 will actually have light coming out of it, but bulb 1 will not.